Now we have a look at the total energy that's going to happen at this instant. So we know that the total energy in the system is 1.6, and we're using that at the top of its flight using mgh, and that we got from question B. So at 4.4, we have to substitute it in to this set of equations. So our 1.6 is our total energy. 0.2 times 10 times 0.4 is our m times g times h. And then the energy of the spring is a half times 5 times 0.4 squared. That's our half kx squared. And then the unknown is a half times 0.2 times v squared. And then we're going to rearrange all of that to solve for v, which is a little bit messy. This calculates out to 0.8, this calculates out to 0.4. That times 2 is this half that's been brought up to this side, and then the square root of the whole ended up being 2 metres per second. Now, there was another way of doing this. You could have done it graphically using the graph to determine what was going on. So if you recall, if you bring the graph back, we can see that this midpoint here is where that maximum speed is going to occur. So we can actually use readings from the graph to determine what's going on. First thing we need to realise is we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sections in this total energy here. So what I looked at was the fact that, well, if I read to here, then that looks like 2.5. So it's 2.5 lots of the energy there, and then this, if I read up through to the mgh, the position, I've got 1, 2, 3, 4.5. So we can use estimates off the graph. And here's the calculations here. So if I take the potential energy at 4.5 graduations, the elastic potential at 2.5 graduations, then adding those two together gives me 7. I know I've got 9 graduations in total, so one graduation will be 1/9 of the total energy. So if I've got 7/9 of the total energy used, it means my kinetic energy should be 2/9 of the total energy. Back to here, our total energy we calculated to be 1.6 joules. So if I do 2/9 times 1.6 equals a half mv squared, I can then substitute that in and find for v, which came out to be 1.88, which isn't exactly the same as 2. But if you were to do this in this method, showing these particular readings, you would most certainly be given full marks for the question. Okay, thanks for listening.